So today we are going to solve this problem, count pairs whose sum is less than target, LeetCode problem 2824. So in this problem we are given an array called nums, okay, called nums, and so which is just a list of number, and we also given a number and it's called target. So our job is we have to find pairs, okay, but so what is pair? So see, a pair means we pick two different positions from the array. Let's call them I and j, and the only rule is I must always be smaller than j, so we always pick the left one first. So we check nums of I place nums of j, okay, so strictly less than target. If yes, we count that pair, okay. So at the end we return the total count of all such valid pairs, okay. So let's try that. So we are given nums of array like -1, 1, 2, 3 and 1, target is 2, 1, target is 2, okay, 0, 1, 2, 3, 4. So now let's check. So first pair is I, j, okay. So I is -1 plus j is 1, -1. So see, we pick index 0, okay, we pick first index 0 and index 1. Nums of 0 is -1 and nums of 1 is 1. So sum of this is 0. So is 0 is less than target. So is 0 is less than 2. Yeah, so we count this pair, okay, -1 and 1. We count this pair, okay, and j comes here. 0 and 2, index 0. So nums of 0 is -1 and nums of 2 is 2. So sum of this is -1 plus 2, it was 1, so is less than 2. So yes, we count this pair also, -1 and 2, 0, 1, 0, 2, okay. So this is an index, and next pair is -1, 0 and 3, okay. Next pair is 0 and 3. So nums of 0 is -1 and nums of 3 is 3. So -1 plus 3 is 2. So 2 is less than 2, no, because 2 is equal. So 2 is equal to 2, so not less than, so we skip this, okay. Now j comes here. So pair is 0 and 4. Nums of 0 is -1 and nums of 4 is 1. -1 plus 1 is 0. So 0 is less than 2. Yes, so we count discount also, okay. -1 and 1, 0 and 4, okay. So if the final answer is 1, 2, 3. So we have found 3 pairs, okay. So the answer is 3. 0, 1, 0, 2, 0, 4, okay. 0, 1, 0, 2 and 0, 4. Now let's take another example. So another example is 6, 2, 5, 2, 7, 3, 2. So let's take another example. So the nums we have -6, 2, 5, -2, -7 and -1 and 3. Target is negative and 3, okay. So the target is -2 now. So the target is -2. Now let's try that. Let's write down the index 0, 1, 2, 3, 4, 5, 6, okay. So the first pair is 0 and 1, I and j. First pair is 0 and 1. So -6 plus 2 is equal to -4. So -4 is less than 2, -2, yes. So -4 is less than -2. So we take this pair also, 0 and 1. Next j comes here, 0 and 2, okay. Next pair is 0 and 2. -6 plus 5. So the answer is -1. So less than -2, no, because one number is line. So -1 is actually to the right of -2, which means -1 is bigger, okay. So we skip this. Now j comes here, 0 and 3, negative 6 plus negative 2, so it was negative 8, so it's less than negative 2 here, so we take this pair. Okay, negative 0 and 3. Now j comes here, at index 4, 0 and 4, and I take negative 6 plus negative 7, it was negative 13, so negative 13 is less than 2, so we take this pair also. Okay, now j comes here, 0, 5, negative 6 plus 1, it was negative 1, yes, negative 1, so it's 7, so 7 is less than negative 2, negative 7 is less than negative 2, so we take this pair also, 0 and 5. Now our j comes here at index 6, 0 and 6, negative 6 plus 3, it was negative 3, so negative 3 is less than negative 2, so we take this pair also. Okay, now we move to index 1. Okay, now I comes here, so j comes here. Okay, I comes here, now j comes here, let's write down neat, negative 6, 2, 5, negative 2, negative 7, negative 1 and 3, 0, 1, 2, 3, 4, 5, 6, so I comes here and j comes here. Okay, so index 1 and 2, pair 1 and 2, so negative 2 plus negative 2, I think negative 2, yeah, 2, so 2 plus 5 is 7, so 7 is less than negative 2, so we skip this. Okay, now j comes here, at index 3 value is negative 2, so the pair is 1 and 3, so 2 plus negative 2, it was 0, so 0 is less than negative 2, so no, so we skip this also. Now we j comes here at index 4, 1 and 4, so we checking the pair 1 and 4. Okay, so negative 2, 1 plus negative 7, negative 1, negative 1. Okay, so it was answer is 1, so 1 is less than negative 2, no, so we skip this also. Our j comes here at index 5, we check this pair, 2 plus negative 1 is 1, so 1 is less than negative 2, so 1 is greater than negative 2, so we skip this. Okay, so our j comes here at index 6, value is 3, at index 6 and value is 6, 1 and 6, 2 plus 3, it was 5, so 5 is less than negative 2, no, so in this case we have changed it 7, 0, this pair 1 and 3. Okay, no, we don't get this pair also because it's negative 2 now. We have just get index 0 and 4, 1 and 4, 2 minus 2 plus 1 and 4, this 2, index 1, 4, negative 7, 2 plus negative 7, it was negative 5, so we get this pair. Okay, 1 and 4. Now let's move our I here at index 2, we move our I at index 2, wait, let me write down here, negative 6, 2, 5, 2, 7, 1 and 3, we have done this 2, 0, 1, 2, 3, 4, 5, 6, now our I comes here and j comes here. Okay, now index 2, now we checking from here, I have processed this 2. Okay, so pair 2 and 3, 5 plus negative 2 is 3, so 3 is less than negative 2, no, we skip this. Our j comes here, 2 and 4, 5 plus negative 7. So negative 2, so is less than negative 2? No, because it's equal, strictly less than, not there. Okay, equal then is not there, so we skip this. Now j comes here. 2 and 5, 5 plus negative 1, so it was 4, so 4 is less than negative 2? No, so we skip this part also. Now j comes here. At index 6 the value is 3. 2 and 6, 5 plus 3, it was 8, so 8 is less than negative 2? No, so we skip this also. Okay, so in this case we don't get anything, so we skip this all. Now our I comes here. Okay, at index 3. Now let's write down. Our I comes at index 3. Negative 6, 2, 5, negative 2, negative 7, negative 1 and 3. 0, 1, 2, 3, 4, 5, 6. So we have processed all of this. Now our I comes here at index 3. Okay, and j comes here. Now let's see. 3 and 4. Let me write down first 3 and 5 and 3 and 6. Okay, first 3 and 4 is negative 2 plus negative 7 is negative 9, so negative 9 is less than negative 2. Yes, we take this pair also. And now j comes here. Negative 2 plus negative 1, so negative 2 is negative 1, it was negative 3. And so negative 3 is less than negative 2, so we take this pair also. So our j comes here. At index 6 value is 3. Negative 2 plus 3 is 1, so 1 is less than negative 2? No, so we skip this. 3, 4, 3, 5. Okay, 3, 4, 3, 4 and 3, 5. Next our I comes here at index 4. Okay, at index 4, wait, I comes here, so we skip this part also. Index 4, 4 and 5, so 4 and 6. Now index 4, 4 and 5. In 5 there was signs. Negative 7 plus negative 1, so it was negative 8, so less than negative 2, so we take this pair also. So our j comes here at index 6. Negative 7 plus 3, so negative 7, index 4, negative 7 and 3 is negative 4, so negative 4 is less than negative 2, so we take this index also. 4, 5 and 4, 6. Okay, we take this index also. 4, 5 and 4, 6. 4, 6, sorry, 4, 6. Now we move to index 5. And I comes here, j comes here. At index 5 pair is 5 and 6, value is negative 1 plus 3, so the answer is 2. So 2 is less than negative 2? No, so we skip this part. So we found total how much pairs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so total we have found 10 pairs. Let me write down here clearly. So the valid pairs are 0, 1, 0, 3, 0, 4 and 0, 5 and 0, 6. So 1, 4, 3, 4, 3, 5, 4, 5 and 4, 6. Okay, so we count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it was 4, 6. So the answer is 10. Let's check the answer. So the answer is 10. Okay. Now see, we pick every possible pairs where I is less than j, so we check if the sum is strictly less than target. Okay, count all valid pairs and return the count. So that's it. The problem is very straightforward once you understand what a pair means and what strictly less than means. Okay, now see. So okay, the first thing is always read the problem slowly and find the most important words. So in this problem the keywords are pairs. So we need two elements, okay, and I is less than j, okay. So left index must always be smaller, so sum is then target, sum less than target, strictly less than not equal to, okay. We have to count, we just need to return a numbers, okay. So in simple words, see, find all two elements combination where the sum is below target, that's it. So always take example. Let me take an example. See, always take small example. Now we take the small example, okay. 1 2 3 and the target is 5. So first ask yourself how many pairs can we even make from 3 elements, okay. 0 1 2. So first is 0 and 1, 1 and 2, 1 and 2. Second is 0 and 2, 1 and 3. Third is 1 and 2, 2 and 3, okay. Only pairs. Now we check each element is 1 plus 2 is 3, so less than 5 years. 1 plus 3 it was 4, less than 5. We take this pair also and this pair also. So 2 plus 3 is 5, so it was less than not from target, so it was equal to target, so we skip this. So we find only two pairs, 0 1 and 0 2, okay. So the answer is 2. So now you can see the pattern, okay. We are checking every possible pairs. Now see, ask yourself, how do we check every possible pairs in code? We need two loops. First loop pick the first element I, and second loop pick the second element j. J always start from I plus 1, okay. If I is starting from here, j will start from here, because I plus 1 is I start from 0 and j start from I plus 1. 0 plus 1 is 1, okay. And because we just always be greater than, because j always be greater than I, okay. So the logic is, say, for I from 0 to end, for j I plus 1 to end. So we check if nums of I plus nums of j is less than target. So if yes, we count will increase, okay, plus plus. So this is called a brute force approach. So we check every single pair one by one, okay. So see, always think about edge cases, okay. So what are the tricky situation that can break our solution? So what if array has only one element? If one element means there are no pair possible, so we return 0. So what if all sum are greater than target, count stays 0, so we return 0. What if target is negative? So do not worry, our logic handles it perfectly, okay. So only after this step, so let's write down brute force code. In C value and the count is equal to 0 for int I is equal to 0 and I is less than nums dot size I plus plus for int j is equal to I plus 1. J starting from index 1 and j is less than nums dot size j plus plus if nums of I plus nums of j less than to target, so COU and the count plus plus. Okay, in last we just return count, return COU and the count. So first row picks I, second row picks j. Starting from I plus 1, check the condition. If row increment the count, in last return the count at the end. Okay, so at the end, so let me submit this. So this is a brute force. It's submit because they contains, so it's see, that's why it was submitting. Okay, now let's try run. We have nums of 1, 2, 3 and target is 5. Okay, so index 0, 1, 2. Now our count is 0, so I is equal to 0. So inner loop start from j is equal to I plus 1, that was 1. Okay, I is 0 and j is 1, so nums of 0 plus nums of 1, 1 plus 2, it was 3, so 3 is less than 5 target, so we increase the count 1. Now okay, we move j at index 2. I is equal to 0 and j is equal to 2, so 1 plus 3, it was 4, so 4 is less than 5, we increase the count, become 2. Okay, now j is 3 out of 1, so that's the array, end of the array in a loop start. Okay, now I comes here at index 1 and j comes here at index 2. So 2 plus 3, it was 5, so 5 is less than 5, no, so count stay 2, j is the end of loop. Okay, so see, now I is equal to 2. 2 means I could start from 3, but array ends at index 2, so inner loop does not even run. Okay, so the answer is 2. So see, we just saw brute force approach and it's worked perfectly for this problem. But now let me show you why brute force can fall in bigger problem. Look at constant. See, now less than or equal to 50. Array is only 50 elements, so brute force is totally fine. But now imagine what if array had 10k elements. Our two loops could run like this. See, 0 0 into 1 0 0 0, so total is 10 0 0 0 10 0 0 operations. Okay, so that is 10 billion operations, and LeetCode only allow 10 millions operations per second, so your code could get a time limit execute error, means your solution is too slow. Okay, now we can use two pointer approach for this problem. Okay, so this work, but we are going to use two pointer approach. Okay, so the idea is, see, so we just saw the brute force work, but it check every single page. Okay, one by one. Now let me show you smart way. The idea is fast and sort the array, then we place two pointer, one at very start and one at very end. Okay, if we have now, so 1 1 1 2 3, so first left pointer start from index 0 1 2 3 4 and right pointer start at index 4. Now see the sum of left and right less than target. If yes, then think about it, the array is sorted, so every element between left and right is smaller than right. Okay, that means left can pay with all of them and the sum will still be lesser than target. So instead of checking one by one, we count all elements at once. That is right minus left, so pairs, then we move left forward. Okay, so if no, the sum is too big, so we move right backward to make the sum smaller. So this is we skip many pairs at once, so that is why this is much faster than brute force. Okay, now let's try that. Let me clear this. So let's take small example only. 1 2 3 4 and target is 5. So we first sort the array, so it is already sorted. Okay, 1 2 3 3. Now we place two pointer left and right and count is 0. See, nums of left place nums of right, so 1 place 4 5. Okay, so 5 is less than 5, no, so the sum is big, we move right backward, so right comes here. Now right is 2, so right is 2, so nums of left is 0, left plus nums of right 0 plus 0 2, so the index 0 1 plus 3 4, so 4 is less than 5, no. Okay, so left can pair with every element between left and right, so count press right minus c, count press equal to right minus left is equal to 2 minus 0 is 2, so count is 2. Okay, we move left forward, so the left comes here, so 2 plus 3, it was 5, so 5 is less than 5, no, we move right backward, so right comes here at index 1. So now see, left is equal to 1 and right is equal to 1, so left is not less than right anymore, so we stop here. Okay, so the count is 2, so the answer is 2. Now let's take another example. -1 1 2 3 1, so the target is 2 0 1 2 3 4. So first we sort this. Okay, -1 1 1 2 3 0 1 2 3 4, so we place two pointer left and right, so we count, see, left and right, -1 plus 3 is 2, so 2 is less than 2, so 2 is less than 2, no, because equal was not allowed, so sum is too big, so we move right backward, so right comes here at index 3. Okay, at index 2, no, 1 0 1 2 3 at index 3. So -1 plus 2 1, so 1 is less than 2, no, so 1 is less than 2, yes sir, so left can pair with every element between left and right, so count place equal to right minus left is equal to 3 minus right minus left, 3 minus 0 is equal to 3, so the count is 3. Okay, so we move left comes here, 1 and 2, 1 plus 2 is 3, so 3 is less than 2, no, so we move right, so right comes here at index 2. Okay, 1 plus 1 is 2, so 2 is less than 2, no, because it equal, so equal was not allowed, we move right backward, right come at index 1, so left and right is equal to 1, left is not less than right, so we stop here. Okay, so the final answer is 3, so the answer is 3. Now let's write down the code. See, we have this array. Okay, because it was not sorted, so the idea is we sort them first, so first we sort the array. Okay, let's go and sort. nums dot begin and nums dot end. Okay, so first we sort, we have array like this. Let me clear this. In our run, the very first thing we did, we sort the array. Okay, we have array like this, 1 1 2 3 1. After sorting, it's look like this, negative 1 1 1 2 3. Okay, so next is we have to place the pointer. In our run, we have place pointer left and right. Left starting from index 0 and right starting from index 4 at last. So we int left is equal to 0 and int right is equal to nums dot size minus 1. So start from last, left start at index 0 the first element and right start at index last, which is size minus 1. Okay, so next count. In our run, we were counting valid pairs, so we need a variable to store that count. Okay, so in count is equal to 0. Next, while rows, if left is equal to 1 and right is equal to 1, in this case we stop. Left is less than right, then stop. Okay, as long as left is less than right, we keep going. Okay, next, if the condition, yes condition, see, wait, so left is 0 and right is 3. Okay, if right comes here, nums of left is 0 plus 0, negative 1 plus 2, it was 1, so 1 is less than 2. Yes, so count plus equal to right minus left, it was 3 minus 0 3. So we move left, move forward. Okay, so left become 1. So we saw that when sum is less than target, left can pace with every element between left and right. So we add right minus left to count all at once, then left move forward. Okay, so let's write down in code. If nums of left is nums of left plus nums of right is less than target count plus equal to right minus left, so left plus plus. Okay, if what the condition is no, if what the condition is no, so left is 0 and right is 4, so negative 1 plus 3, that was 2. So 2 is less than or equal to 2, no, so we'll move right backward, so right becomes 3. Okay, so when sum is not less than target, the right value is big, so we move right backward to make the sum smaller. So in this code we write just else right minus minus. Okay, in last we just return the count. So first step is we sort the array nums, and next is left pointer, right pointer, initialize count. So we keep going here, and next is the condition if yes, while if nums of left plus nums of right is less than target, count plus equal to right minus left, so in this case left to plus, it was right or not, we don't have to write this. So the time complexity of this code is big of n log n. Okay, so we did two things in our code. First is sorting and next is while loop. So the space complexity is big of 1. So now look at our code. See, we just take what extra variables we did create, left, right, count, just 3 simple integer variable, that is no extra array, no extra list, nothing. Okay, so that's it. Let me submit this. That's all.